It's now time to look in more detail at the functions you can add to a test device file. This video will show you the different scopes applicable to functions, describe some common keywords, and take a brief look at flow control. It'll give you a good grasp of the basics of XJE's functions so that you'll be ready for the rest of the series, which covers how to create your own test device files. To get an overview of the code first, look at this simple example for an LED. After initial constant and variable declarations, individual functions begin with this optional block of text called the XJEsDoc entry. The function itself then starts with its declaration and finishes at the end statement. This test device file contains 3 functions, and each one starts with the XJEsDoc entry, followed by its declaration. You can add additional comments into the code by putting 2 forward slashes on the line in front of the comment. So, let's go back now and look at the code in more detail. First, variables, and there are 3 main types: int, string, and file. For integers, there's no upper limit on their size, and you don't have to define a size because integers will automatically expand as necessary. Note, though, that XJE's support is limited to unsigned numbers, so you can only use positive integer values. If you're dealing with data that would normally need decimals, it's best to change to smaller units. For instance, 3.054 volts would be better handled as 3054 millivolts. The string variable type is used for strings of any length, and the file variable type is used for opening, reading, and writing files. You also need to be aware that XJE's is case-sensitive, so if you've defined a variable using all uppercase, but then later try to call it using a lowercase name, you'll get an error. Moving down through the code, look at the XJEsDoc entry. It's identified by these 3 forward slashes at the start of each line and provides a structured way to document the function. At the start of this block, you can provide details of what the function does. That's useful when someone else looks at the code later. After that, there are some tags you can use to describe the function's input and output parameters. Each parameter tag needs a new line and starts with this @param tag followed by the variable's name, in this case, result, and then text to describe what it's for. In this example, the function only has 1 parameter. You can also add a line for a test function tag. This tells XJDeveloper to offer the option of automatically adding the function to the test list. You can use the tag by itself, or, as in this example, you can add additional arguments. You can use default disabled or default enabled to set whether or not the function will be enabled when it's inserted. A group name tag can also be added to the line if you want to specify a specific test group to be used. Below that, you come to the code for the function itself, which starts at the function declaration and finishes at the end keyword. In this example, the function's called test. This particular one has just 1 output parameter and has been given global scope. This is a good point to think about scope a bit more. There are 3 types of scope to consider: local, internal, and global. Local is the most restrictive. This is for a function that's only used within the same file. For example, you might have a test device file with a function that calls several small subtest functions and then returns the overall result. Each of those subfunctions would be given local scope. This function can't be called from any other files or the test list. Next, there's internal, which is a little less restrictive. It still allows a function to be called from anywhere within the same file, but the difference comes when you have a test device file with associated additional code files. An internal function in an additional code file can be called from the test device file it's associated with, and also from other additional code files associated with the same test device file. It still can't be called from the other code files which aren't associated or from the test list. Then we get to global. A function with this scope can be called from anywhere, including from the test list, and we'll talk more about functions that are suitable for the test list in the 8th video. By the way, if a scope isn't defined, it will default to global. It's good practice to limit the scope as much as you can. That'll reduce the chance of calling the wrong function and means you don't have to worry about functions in other files having the same name. And with that, let's move on and look at syntax. Input and output arguments are defined in parentheses. All input arguments are listed in the first set, and return parameters in the second. If nothing is passed in or out, the parentheses are simply left empty. Items in blue are keywords. Along with standard ones for things like data types and flow control, there are some XJE-specific keywords. They're all listed in the XJTag help system, but let's look at a few of them here so you can get an idea of the kind of things they do. There are some that are specific to board testing. For example, the set statement is the main mechanism for reading or writing buses. Setting a bus to I turns off the output stages of all pins in the bus to make them high impedance. There are other keywords that are useful when displaying information about test results. For instance, there's board_name and unique_device_ref, which is a string containing the name of the current device, such as IC4. Then there are functions for user interaction, such as input box and message box, and ones for variable formatting, such as bin and hex, which allow you to print output in binary or hexadecimal. Now let's move on to look at flow control within a function. Again, there's a complete list in the XJTag help system, but I'll show you a few of the common ones here. A for loop is structured like this, where all statements are executed for each pass round the loop. Then there's the do-while loop. This can be structured in several different ways. For example, here the while expression is evaluated in the middle, but it can also be put elsewhere. If it's evaluated at the start like this, it becomes equivalent to the while loop found in most languages. Put it at the end, however, and it's then equivalent to a do-while loop. An if statement is used like this. The first block of code is executed when the if statement evaluates as true, and program execution then resumes after the end keyword. If it's false, any else-if statements get evaluated instead, and if none of those evaluate as true, any concluding else statement gets executed. The final one to show you is the switch statement, which is structured like this. Flow control is determined by matching an input parameter to a collection of integers or strings. You can also add a default clause at the end. Its statements are executed if none of the case statements matched. By the way, if you want help on a keyword, highlight it and press F1 on your keyboard. Up it comes. That's the basics of a test device file covered, so it's now time to see how to create your own from scratch. The rest of this series deals with that, so I look forward to starting it with you in the next video.